Hi! Now we're going to tackle about trapezoidal rule method. So first, what is trapezoidal rule method? Trapezoidal rule method is a method for approximating a definite integral using linear approximations of a function of f. Has a faster convergence in general compared with the Simpson's rule. Tends to become extremely accurate when periodic functions are integrated. And now we have this formula for trapezoidal rule method. The first one will be used for numerical integration, while the other formula is used for multiple integrals. We have here this function of x equals 0.4 plus 10x plus 17x squared, having its limit a equals to 0 and b equals to 1. We're going to solve this using the trapezoidal rule for multiple integrals. Our next topic will be the Simpson's method. So what is Simpson's method? A method for approximating a definite integral using parabolic approximations of function of f. Gives a better approximation than trapezoidal rule method. A Newton-Cotes formula for approximating function of f. The formula for Simpson's rule will be I is equals to quantity b minus a multiplied to the quantity of function of x sub 0 plus 4 times the summation of the function of xi plus 2 times the summation of function of xj function of x sub n all over 3 times n. The summation of function of x sub I will be the odd step size values, and the summation for function of x sub j will be the values in even step size. Now let's solve the function of x. Our formula for forward divided difference will be the function of x sub I equals to function of x sub I plus 1 minus function of x sub I all over h, or the step size. For backward divided difference, we have the function of x sub I minus function of x sub I minus 1 all over h. And for our central divided difference, we have function of x sub I plus 1 minus function of x sub I minus 1 all over 2 times height, or the step size. Since our initial value of x is 0.5, we can now find the function of x sub I minus 1, that will be the function of 0, and the function of x sub I plus 1 will be the function of x 1. And now let's get the values of forward divided difference, back divided difference, and the central divided difference of the equation by substituting the values that we had obtained earlier.